Hi, this is Namita from Sri Venkateswara College of Engineering, studying at Information Science and Engineering Department. So today's topic is file system structure and file system implementation. The overview of this video is introduction, what is a file system structure, virtual file systems, file allocation methods, types of file system evolution, directory structure, partitioning, in-memory file systems, network file systems, distributed file system security, file system maintenance, file system performance, and conclusion. Introduction. Welcome to my presentation on file system structure and file system implementation. Today we will be exploring the fascinating world of file systems and how they work. Have you ever wondered how your computer stores and organizes files? How does it manage to find that one document you saved months ago? These questions and more will be answered as we get into the slides of file system. What is a file system? A file system is a way of organizing and storing files on a computer. It provides a structure for the files to be stored, accessed, and managed. Think of it as a virtual filing cabinet that keeps all your documents organized and easy to find. Without a file system, your computer would not know where to store or retrieve your files. File system structure. A file system is comprised of multiple layers, each with its own unique purpose. At the lowest level, there is a physical layer which consists of actual hardware used to store data. Above that is the logical layer which manages how data is stored and accessed on the physical layer. The next layer is the file system specific layer which defines the structure and organization of files and directories within the file system. The file system specific layer can be further broken down into several components, including the boot block, superblock, inode table, and the table blocks. Virtual file systems. A virtual file system (VFS) is a layer of software that sits between the operating system and the file system it supports. It provides a common interface for accessing different types of file systems, allowing them to access in a uniform way. The VFS abstracts away the differences between the systems, providing a consistent set of operations that can be used to access files and directories. File allocation methods. There are several different methods used for file allocation in a file system, including contiguous, linked, and indexed allocation. Contiguous allocation involves allocation files in a system continuous block of space on the disk. This method is simple and efficient, but can lead to fragmentation as files are detected and new ones are added. That is, they will be deleted and new ones will be added. Linked allocation involves linking together free blocks of space on the disk to form a file. This method allows for more flexible use of disk spaces but can be slower due to need of traverse the linked list. Index allocation involves using an index blocks to store pointers to the location of each file on the disk. This method is efficient and allows for easy access to files but requires additional overhead in maintaining the index block. File system implementation. File system implementation refers to the process of creating and managing a file system on a storage device. There are several types of file systems, each with its own unique features and characteristics. One common type of file system is FAT file system, which is used by many older operating systems. Another popular file system is NTFS, which was introduced with Windows NT and is still widely used today. Finally, there is the ext file system, which is commonly used in Linux-based operating systems. Types of file systems. There are several types of file systems commonly used in computer systems today, each with its own strengths and weaknesses. One of the most widely used file system is FAT, which stands for File Allocation Table. This file system is relatively simple and easy to use, but it has some limitations in terms of file size and storage capacity. Other popular file systems is NTFS, that is New Technology File System, which is developed by Microsoft. This file system offers improved performance and security features compared to FAT, that is FAT, and can support larger files and volumes. A newer file systems has gained popularity in recent years is ext4, which is a journaling file system used in many Linux distributions. This file system offers improved performance and reliability as well as support for larger file and volumes. File system evolution. The history of file system development can be tracked back to early days of computing when data was stored on punched cards and magnetic tape. These early systems were simple and limited in their capabilities, but they paved the way for more sophisticated file systems that was emerged in the years to come. In 1960s and 1970s, the first hierarchical file systems were developed, including IBM's Virtual File System (VFS) and the Unix file system (UFS). These early file systems introduced the concept of directories and subdirectories, allowing users to organize their files in a logical and initiative way. As computers became more powerful and storage capacities increased, file systems evolved to support larger files and more complex metadata. Directory structure. A file system directory is a hierarchical structure used to organize files and folders in a logical manner. Directories can contain subdirectories, which in turn can contain more subdirectories, forming a tree-like structure. The root directory in the top level directory and in the hierarchy, while the subdirectories are located below it. Naming conventions for directories typically follow a specific format, such as using forward slashes to separate directory names. For example, path, home, user, documents would indicate that the documents directory is located within the user directory, which is located within the home directory. Partitioning. Partitioning is the process of dividing a physical storage device into multiple logical sections, each with its own file system. This allows different types of data to be stored separately, improving organization and making it easier to manage large amount of information. In addition to improving organization, partitioning can also improve performance by allowing different file systems to be optimized for specific tasks. In-memory file systems. In-memory file systems are a type of file system that stores data in memory instead of disk. This allows for faster access to data as there is no need to read from or write to a physical disk. In-memory file systems are commonly used in situations where speed is critical, such as in high performance computing or real-time systems. One advantage of in-memory file system is their speed. Since data is stored in memory, it can be accessed much more quickly than if it were stored on the disk. Network file systems. Network file systems are a type of file system that allows access to files and directories over a network. This means that user can access files stored on remote servers as if they were stored locally on their own computer. One advantage of network file system is that they allow for easy sharing and collaboration between users. For example, multiple users can work on the same document at the same time. Distributed file systems. Distributed file systems are a type of file system that allows multiple computers to access and share the same files. These systems are designed to handle large amounts of data and provide high availability and fault tolerance. One popular example of distributed file system is Hadoop Distributed File System, that is HDFS. File system security. File system security is a critical aspect of computer systems. It involves controlling access to files and directories as well as ensuring the data is protected from unauthorized access or modification. One common security measure used in file system is file permissions. These permissions determine who can access a file and what actions they can perform in it. File system maintenance. File system maintenance is an essential task that helps ensure the longevity and reliability of a file system. One important aspect of maintenance is disk defragmentation, which involves rearranging files on a disk to improve access times and prevent fragmentation. This can be done using built-in tools like Windows disk defragmentation or third-party software such as Defragler. File system performance. File system performance is a critical factor in ensuring efficient and effective data storage and retrieval. Factors such as disk speed and fragmentation can significantly impact file system performance. Disk speed refers to the speed at which data can be read or written from the disk. Fragmentation occurs when files are split into smaller pieces and scattered across the disk, making it more difficult to the disk to retrieve the data quickly. To improve file system performance, various techniques can be employed, such as caching or prefetching. Caching involves storing frequently accessed data in memory so that it can be retrieved more quickly. Prefetching involves anticipating which data will be needed next and retrieving. File system backups. One of the most important aspects of file system management is ensuring that backups are regularly performed. Backups can help protect against data loss in the event of hardware failure, software errors, or even malicious attacks. There are several different backup strategies that can be used, including full backups, incremental backups, and differential backups. A full backup involves copying all data from file system to external storage device, such as a hardware drive or tape backup. Incremental backup only copies files that have changed since the last backup, while differential backups copy all the files that have changed since the last full backup. It in advance. Conclusion. In conclusion, we have covered a lot of ground in this presentation on file system structure and implementation. We started by defining what a file system is and how it is used, then dwelled into the different levels and components of file system structure, including the file allocation methods and directory structure. We also discussed various methods of file system implementation, such as in-memory file systems, network file system, and distributed file systems. Additionally, we explored the importance of file system security, maintenance, and its performance. As technology continues to evolve, file system structure and implementation will remain an essential topic to master. Thank you.